This course is intended to combine different subjects related to the issues of climate change, so that students can gain a general knowledge of the issue, as well as of the strategies that have been developed in legal and environmental economics. We shall deal with climate change and its relationship with energy from two approaches: mitigation and adaptation. In the field of energy, we distinguish between the technologies with the greatest impact on the reduction of emissions as follows: more efficient conversion of fossil fuels, use of low-carbon fossil fuels, capture and storage of CO2, nuclear energy, and the development and application of renewable energy sources. Each of these options has its own characteristics that determine its cost-effectiveness as well as its social and political acceptability. Costs such as the effect on the environment must be estimated on the basis of the analysis of complete life cycles. In this module, we shall see these aspects as related to each type of energy source. Any energy system should be considered with a view to contributing to sustainable development. For this reason, the energy challenge must aim to ensure the supply of energy, but at the same time take into account the aspects that have to do with the effects on the environment, attempting to minimize them, but without overlooking the fact that all energy systems must be both economically and environmentally competitive. Also necessary are the following: having a supply of energy that covers demand, having information from different production technologies or about the generation of components required to meet the demand in real time, consideration of the different mechanisms of supply, storage, transport and distribution, a study of the consumption of energy and its uses. Energy consumption is distributed among the three sectors of economic activity, in which households must also be included. These sectors are the primary sector, the secondary sector, and the tertiary sector. Finally, consideration of the effects of the use of energy on the environment. An energy system is based on the following aspects: the energy demanded to meet needs, considering that energy is present in all aspects of individual and social life. Determination of the amount of energy required, calculating how much energy we need. The allocation of production costs and benefits. It is necessary to determine the energy costs of energy services in a rational way. And finally, selection of the sources of energy and forms of production. The impacts on the environment to be considered are related to the disturbances generated in the different activities or processes that occur along the energy cycle. First, we have extraction activities. Pollution arises from mining coal or oil and other activities. We must also consider the environmental impact brought about by the construction of dams. Energy generation activities produce solid, liquid, and gaseous emissions, as well as thermal pollution. Pollution from nuclear energy must also be taken into account. Land use and the possible alterations due to this must also be considered. In the distribution stage, spills, either of solids or of liquids, may occur. There is also the possible environmental impact of high voltage lines, as well as the impact of gas pipelines, which also have to be taken into account. The use of energy can generate solid, liquid or gaseous emissions. We should also consider pollution inside closed spaces, namely thermal and acoustic pollution. Regarding the energy sector, there are a number of contaminants that are considered to be of importance, such as CO2. This is the main greenhouse gas. Over the past 100 years, an increase in the concentration of CO2 in the atmosphere of slightly more than 30% has been recorded. The current fear is that this greenhouse gas, along with others such as methane, is causing a significant increase in the average temperature of the Earth. This will give rise to climate change, although the nature of such change has not yet been well defined. Evidence of this phenomenon can be seen in the shrinking of glaciers and the polar ice caps. Regarding sulfur dioxide and sulfur trioxide, SO2 and SO3, many industrial processes, including the burning of coal, release gases or substances containing SO2 and SO3, which are the precursors of acid rain. Compounds called chlorinated fluorocarbons, CFCs, are also important. These were initially used as refrigerants in both household and industrial cooling appliances. Nuclear waste. Its management, which should include its management per se, reprocessing and storage, is still an unresolved issue. Moreover, the volume of this kind of waste will increase as older nuclear power stations begin to be decommissioned. Nitrogen oxides, or NOx. These are products of combustion at temperatures of about 800 degrees centigrade, and they are the precursors to the formation of ozone in the lower atmosphere. Although ozone is good at a height of 60 kilometers, it is harmful at ground level. This is mainly because it is a strong oxidizer, with harmful effects on the skin, mucous membranes, and organs in general. Different chemical wastes, in some cases generated abundantly, have their own different compositions. Let us see graphically what the so-called greenhouse effect actually is. Greenhouse gases absorb infrared radiation emitted by the surface of the Earth, by the atmosphere itself due to the presence of the same gases, and by clouds. Atmospheric radiation is emitted in all directions, even towards the Earth's surface, and greenhouse gases trap the heat within the Earth's troposphere. This is known as the natural greenhouse effect. An increase in the concentration of greenhouse gases produces increased infrared opacity in the atmosphere, and therefore an effective radiation into space from higher up and at a lower temperature. This causes a change of the net heat flux, which is the difference between incoming solar radiation and outgoing infrared radiation, thereby generating an imbalance that can only be compensated by an increase in the temperature of the surface troposphere system. This is called the increased greenhouse effect. The Intergovernmental Programme has provided charts for climate change in 2007, where the following can be seen. In Chart A, we see the evolution of the emissions in equivalents of CO2 per year. Note the considerable increase between 1970 and 2004. Chart B. This shows the values of the different gases produced by human activities, where the generation of CO2 due to the burning of fossil fuels is clearly important, followed by the production of CO2 due to deforestation. The sum of both reveals the major role of CO2 in the processes of climate change. Chart C. Here we analyze the participation of the different sectors in the generation of emissions of greenhouse gases. Note that the energy supply has the greatest contribution. Let us now look at the phenomenon called acid rain and its implications for the environment. The gases involved are oxides of sulfur and nitrogen, which are transformed into the corresponding acids, and, on settling on the ground, they generate the following phenomena. They increase the acidity of the waters of rivers and lakes, causing significant damage to aquatic life. They increase soil acidity, producing changes in soil composition. They are directly harmful to the vegetation exposed to acid rain, leading to the death of many species. Even historical buildings built of limestone undergo a transformation of the limestone into gypsum according to the following chemical reaction. The process is known as stone sickness and leads the stone to collapse. The equation is CaCO3, which is limestone, plus H2SO4, acid rain, is transformed into calcium sulfate, which is gypsum, plus CO2 plus H2O. And finally, we should note that the corrosion of metallic materials occurs at a much higher rate than usual. This figure shows the effects of several pollutants mentioned previously and the systems they attack. We see that groundwater, terrestrial and marine ecosystems, and the climate are affected, and these pollutants also affect people's health. This should be addressed in greater depth because they affect the whole population, with the corresponding negative economic effects. Here we see the different effects of greenhouse gas, GHG, emissions due to different human activities. All ecosystems are affected, and many of these effects will be visible in the long term. Climate change results in a series of conditions that affect the temperature, rainfall, and sea level, which in turn have effects on health, as referred to diseases directly related to climate change. Also on agriculture, due to its dependence on resources, water and soil, forests, i.e. changes in their composition, effects on water as a resource, referring to difference in geographical distribution, coastal areas with flooding, and different ecosystems, referring to loss of habitat and alterations to it. The following two slides show different primary energy sources, their intended applications, the positive aspects and the impacts of each. Slide 17 depicts the conventional sources of energy, that is coal, oil, natural gas, and nuclear power. Slide 18 shows renewable energy, biomass, solar, wind, geothermal, and mini hydraulic plants. It is possible to compare each of these energy sources, see which aspects are the most important, their negative aspects, environmental considerations, economic aspects, and so on. Note that to perform an analysis of the most appropriate technology in each case, it is necessary to carry out a study of all these parameters. Some aspects of the environment that are related to thermal power stations are emissions into the atmosphere, the production of ash and slag, thermal pollution from cooling towers, and finally the generation of effluents and chemical residues. All these have associated environmental and economic implications. However, combined cycles have less impact on the environment because the amount of fuel required per kilowatt-hour produced is reduced, resulting in a reduction of polluting emissions, that is, sulfur oxides, nitrogen oxides, carbon dioxide, and methane. Renewable energies have a reduced impact or even no impact at all on the environment with respect to the use of fossil fuels. In the first slide, we see the impact that wind power, geothermal, hydro, and solar energy have on ecosystems, the land where they are installed, and also their impact on the generation of noise, visual impact, and so forth. It also depicts the drawbacks in terms of current costs for purchase and installation. Also, the difficulty of storage, and hence the inoperability of such installations at certain times. The other slide shows the characteristics of different types of biomass when applied for the generation of power. A Stanford University study established a ranking of renewable energies based on the ecological footprint, the impact on the environment, and health benefits. With these parameters, it establishes the ranking shown in the slide, which highlights wind power as being the most appropriate. This table compares CO2 emissions per kilowatt-hour generated, which come from different energy sources. Note the high emissions produced in the process of energy generation through combustion, and the low levels of emission produced by wind, hydraulic, and nuclear power. Let's have a look at how we go about carrying out a life cycle study, in this case applied to the different sources of energy generation. To do this, we must first consider the global impacts of the different energy sources, shown in a table prepared by the Spanish Institute for the Diversification of Energy, IDAE. We see that these impacts include climate change, the failing ozone layer, acid rain, and effects on biodiversity. According to the same study, the most important local impacts will be the progressive depletion of resources, emissions into the atmosphere, and water and soil pollution, the generation of waste materials, soil use, the generation of noise, and impacts on the landscape. Each of the different energy sources will have effects on some of these impacts. Analysis of life cycles is a tool for managing the environment that includes all the inputs and outputs from it in one single process. In the case of energy generation, we must also include extraction, processing, transport, and storage, together with supply, consumption, and the generation of waste. The following stages must be included in the analysis. First, the definition of the aims and reach. In this study, a comparison is made of 8 electricity production systems. In the case of conventional systems, we have carbon, oil, natural gas, and nuclear energy, while for renewable energies we have wind and hydroelectric energy, with reference to mini plants, together with photovoltaic and thermosolar energy. We also need an analysis of the inventory, where the associated environmental loads are analyzed. The evaluation of impacts, in which the inventories are interpreted and assessed. And finally, the interpretation of the results, where the environmental damage is assessed. This table shows the data from the study assessing the environmental impacts of the 8 systems of energy production, and the plot is shown in the next slide. Note that, as measured in ecopoints, the energy produced by combustion has the highest values, while the mini hydro plant has the least impact. Here we have a reference scenario that shows the forecast for political conditions without changes in the reduction of emissions, and also 2 alternative scenarios projected for 2030. One would limit the concentration of emissions to 450 ppm of equivalent carbon dioxide, CO2 equivalents, and an increase in temperature of 2 degrees centigrade. This is believed, however, to be virtually unattainable. The other one is more feasible. That is, the concentration would be at 550 ppm and the temperature rise would not exceed 3 degrees centigrade. For the 550 ppm scenario, the peak of emissions would be reached by 2020, thereafter dropping off. The 450 ppm scenario would require even greater reductions after 2030. World energy demand will grow by 32% and will need to seek a stronger niche in which to search for renewable sources and greater energy efficiency. This will have to be accompanied by a decline in the demand for oil and the implementation, already underway, of power plants able to capture and store carbon. These are chiefly to be found in OECD countries. Energy-related CO2 emissions will reach the 33 gigaton level at the end of the period. This slide shows the different contributions foreseen for the different technologies proposed to reduce CO2 emissions. Included are the capture and storage of CO2, CCS, nuclear energy, renewable energy, and different ways of achieving energy efficiency. Outstanding is a prominent role that different renewable energies and energy efficiency must play in these reductions. This slide shows the change in global temperature at the surface of the Earth in the different scenarios. These scenarios are coherent and consistent descriptions of how the Earth's climate system may change in the future. They include a similar storyline in regard to demographic, social, economic characteristics, and technological change, and they consist of 4 families of scenarios, A1, A2, B1, and B2. The A1 storyline and scenario family describes a future world of very rapid economic growth. The A2 storyline and scenario family describes a very heterogeneous world. The B1 storyline and scenario family describes a convergent world with the same global population, which reaches its highest level in the middle of the century, thereafter decreasing. The B2 storyline and scenario family describes a world where the emphasis is on local solutions to economic, social, and environmental sustainability. Latin American and Caribbean countries contribute to 80% of the total emissions in the region through emissions from Brazil, Mexico, Venezuela, and Argentina. They account for 9% of the world's total. The development of emission reduction policies should consider all sectors involved. The objectives of the policies currently contemplated or implemented in the area are directed at, first, reducing emissions related to energy consumption, and second, containing or reversing the level of deforestation and soil degradation. To design energy policies that will help to mitigate the effects of climate change, it is necessary to know what the energy forecasts will be like. We see that in the Latin American and Caribbean area, demand will be similar to the European zone and well below countries such as China. We also note that demand for carbon sources will be low in the area as compared with other energy sources identified as appropriate for the fight against climate change. Nevertheless, this demand for energy will be very high in China, while for the area of Latin America and the Caribbean there will be a smaller increase in CO2 emissions. In this graph, we can see the forecast that the Economic Commission for Latin America and the Caribbean, known as CEPAL, published concerning the natural phenomena that will be modified. We see areas in which changes in precipitation will lead to both increases and decreases, as well as increases in temperature. Here, the plots compare the number of CDM projects. CDM refers to Clean Development Mechanisms. We see that Latin America and the Caribbean have a significant contribution with respect to other areas of the world, with the exception of Asia. By countries in the region, Brazil leads this sector, followed by countries such as Chile, Peru, Mexico, and Honduras. By technologies, the hydroelectric sector leads such CDM proposals, followed by the production of methane, the use of biomass, and monitored landfills.